Pennies made prior to 1984 are pure copper and weigh a little bit more than pennies made after 1984, which have zinc inside and they're lighter. If we weigh each one, we see that the older pennies are about 3.14 grams, whereas the newer pennies are only 2.49 grams. In the chart here, what we did is weighed 5 different pennies. If we add these all up, we could find their average mass. The total mass is 13.72 grams. And then to get the average, of course, what we do is divide by 5, and that'll give us an average of 2.74. So of these 5 pennies, the average mass is 2.75. Now, if we had a large sample of them and we wanted to find the average mass, it would be like calculating the weighted average of isotopes. In this case, we have 2 kinds of isotopes of penny 249 and penny 314. What we would have to do is sort them out somehow and find their total mass. We can do that on this device, the penny sorter. The way it works is that when we roll these pennies down this ramp, the heavier old pennies will go into the near bin and the lighter newer pennies will go into the far bin. Sorting them this way, we don't even have to look at what their dates are, which would be very tedious. So we can sort our pennies this way, fast as we can put them in there. Now we finished sorting our pennies, and we have a bin of the heavier old pennies, the lighter new pennies, which came out to be 79.96 grams. And the older, heavier pennies came out to be 36.50 grams in the sample that we had. This will give us a total mass of the sample of 116.46. So that's the total of our sample, including both types of pennies. Now, to figure out what percentage of each there is, we have to take the part divided by the whole. So 79.96 out of 116.46 times 100 will tell us the percent of the lighter pennies. And then we have 36.50 out of 116.46. That'll tell us the percentage of the heavier pennies. That will give us 68.7% for the lighter pennies and 31.3% for the heavier pennies. If we add those 2% together, we should end up with 100%. The next thing we need to do is calculate the weighted average. So what we would do here is take the mass of each isotope, 2.49, times its percent. Now in this case, 68.7, but I'm going to type that in the calculator as 0.687, a decimal, and then I'll get the mass contribution of that particular isotope. 2.49 times 0.687, 1.71. And then we do that for the other isotope, 314 times its percent, written as a decimal, 0.313, 0.98. We call each of these the mass contribution. To get the weighted average, then, we would simply add those together. That gives us 2.69. All right, that now is our weighted average. Note now we don't divide by 2, we just simply add up those contributions. All right, an average should end up somewhere in between the two actual values. It'll be closer to whatever one is the higher percent. So 2.69 is closest to 2.49, but still in between the two. Now, calculating the weighted average this way using the masses of this does not require that we actually count up all the pennies. Now, if we knew how many there was, we could find the percentages with the number of pennies as well. For example, if I had 35 total pennies and 24 of them were the 2.49 variety, then that percentage would come out to be 68.6%, which is close to what we got. And then there would be 11 out of 35 for the other one, which will come out to be 31.4%. Also close to what we had here. In conclusion, we can calculate a percent abundance using either a mass of a part divided by the mass of the total, or number of the part divided by the number of the total. Either way, we'll get the same percentage. Then when we go to calculate the percent abundance, we take the percentage, turn it into a decimal for the calculator, and we can figure out a mass contribution for each isotope. Then the average, weighted average, then we would just add them all together. All right, and that is how we do it on the periodic table. We take all the known isotopes, weigh them out somehow, we have to separate them, and then we figure out a weighted average, and that's how we get the atomic weight that is on the periodic table.